Dear students, welcome to today's class. So today I am going to explain a very important chapter for your JEE mains examination and your board examinations. So the chapter is inverse trigonometric functions. Okay now. So you even though if you didn't get a direct problem from this inverse trigonometric function, these concepts and formulas are very important to solve another problems from different branches of mathematics. Okay now. So let us start our class. So what is inverse trigonometric functions? Before starting this inverse trigonometric functions, first let us skip this word. Let us for time being skip this word, that is trigonometric. See what is inverse function. What is inverse function? First concentrate on that. What is inverse function? I already completed the chapter functions. In that I explained that inverse function. What is inverse function? I will explain it. If f is a function from a to b is a bijection. Bijection means what? Mali cheppantara. Let f from a to b is a bijection. Bijection means what? Both 1 and onto function. For example, I will take one example. A and B are two non-empty sets. Let A contains the elements 1, 2, 3, 4. B contains the element x, y, z, w. Okay now. 1 is mapped onto x, that means x is the image of 1. 2 is mapped onto y. 3 is mapped onto w. 4 is mapped onto z. Then clearly it is a 1 function. It is a 1 function. Why it is a 1 function? No two elements of A have the same image in B. That means one element have one image. One element have one image. No two elements have the same image. Actually, by definition of function, two elements of the domain can have the same image in codomain. But here the specialty of this function from A to B is no two elements of the domain have the same image in B. That's why it is a 1 function. Now coming to another property it satisfied by this function is, observe the codomain. What is the codomain? X, Y, Z, W. What is the range? Range also x, y, z, w. That means codomain is equal to range. That means every element of codomain is the image of at least one element of domain A. That's why it is an onto function. It is both 1 and onto function. That's why it is called a bijection. Then there exists a function from B to A. From B to A is also a function. So 1 is the image of x, 2 is the image of y, 3 is the image of w, 4 is the image of z. There from B to A is also a function. That is denoted by f inverse from, it is a function from B to A. That is a notation. F is a main function from A to B. F inverse is a function from B to A. So the domain is B, codomain is A. So this is called a inverse function. So to have a inverse function, the original function should be a bijective, both 1 and onto function. Now coming to trigonometric functions. So as we know that all trigonometric functions are not bijective. All trigonometric functions are not bijective. Why? Very simple example I will tell. What is sin 30? Simple example. Sin 30 degrees is equal to 1 upon 2. Everybody knows sin 30. Not only sin 30, as we know that sin 120 degrees is also 1 by 2. Sorry, 180 minus 30, 150. Sin of 150 degrees value is also 1 by 2. That means 30 sin 130 and sin 50 will have the same image 1 by 2, 1 by 2. Therefore, it is not a 1 function clearly. Therefore, it is not a bijection. Okay now. So, all trigonometric functions are not bijective, but we can make them as bijective by restricting the domain, by cutting the domain. So, here what is the domain of sin theta? Set of real numbers. So, I will cut the domain. I will cut the domain in the both the direction, from the negative direction in positive. I will cut the domain and I will make it into bijection. Okay now, I will make it into both 1 and 2. So, where we have to cut. Okay now, so let us see that. I am going to explain trigonometric function y is equal to sin x. So, if you understand one trigonometric function clearly, when it is bijective and in what domain it is bijective, clearly, detailedly, the remaining 5 trigonometric functions are also follows the same logic. Okay now, observe this sine function. As we know that this sine curve, sine graph passes through origin and it takes maximum value at pi by 2, 5 pi by 2 like that, and it takes minimum value at 3 pi by 2 like that. It is a sine curve I have drawn. We have learned it so many times. Now, if you observe this, on the whole it is not a bijective. Why? Because you take a horizontal line test you take. So, if you draw a horizontal line, it cuts the graph more than once. Therefore, it is not a bijection. All those things we know that. Why? Because for some pi by 2 value is 1, sir 5 pi by 2 value is also 1. Therefore, for both 5 by 2 and 5 pi by 2, it is not a 1 function, it is clear. Now, what I am going to do is, its domain is set of real numbers. Domain is set of real numbers. What is the range of this function? You know that -1 to 1 closure bracket, that is maximum value is 1, minimum value is -1. Now, what I am going to do is, I am cutting the domain. So, here domain is set of real numbers, total domain. So, what I am going to do is, I am going to cut the domain here minus pi by 2, sorry, plus pi by 2, here also minus pi by 2, I am cutting. Observe the graph from here, from 0 to, minus pi by 2 to plus pi by 2. So, this graph up to here only you observe, it is from minus pi by 2 to plus pi by 2, it is both 1 function and onto function. Both 1 function and onto function from the interval minus pi by 2 to plus pi by 2. You may ask one doubt, sir, from pi by 2 to 3 pi by 2, here from here to here also it is 1 and onto function. Yes, what you said is right. From here to here, minus pi by 2 to minus 3 pi by 2, it is also a 1 function. Yes, it is also a 1 function. That means, in every interval of length 2 pi, interval of 2 pi, that is why we say that it is a period is 2 pi. So, for every interval of length 2 pi, the graph is periodic and moreover it is bijective. That means, from minus pi by 2 to plus pi by 2, you take any value, any angle, you will get only one image. So, from minus pi by 2 pi by 2, the function is from minus pi by 2 to plus pi by 2, f is equal to sin x is bijection. We will, for the definition purpose, we will take this interval only, minus pi by 2 to plus pi by 2. Okay na? But you can take from pi by 2 to plus 3 pi by 2. For the fundamental definition, we will take the interval minus pi by 2 to plus pi by 2, including minus pi by 2 to plus pi by 2. Okay, now if you take in that interval, every element have a one and only one image, and it is also a onto function. That's why. So I have removed this domain. So this is the domain. For this part also I removed, and I also removed this part also. Okay, now I removed this part. So from minus pi by 2 to plus pi by 2, the function is a both 1 1 and onto function. Therefore, a function defined from what is the now domain? Minus pi by 2 to plus pi by 2. What is the range? As usual, from minus 1 to 1. The function f defined as f of x is equal to sin x is bijective. Bijection is a bijection. That means it is both 1 1 and onto function. Understand? So I have divided, I have cutted. So from my plus pi by 2 to infinity, I cut, and this side minus pi by 2 to minus infinity, I cut in the both the direction. I have taken the interval minus pi by 2 to plus pi by 2. That means I restricted the domain. I have restricted the domain. So here the domain I restricted. From here to here, the function is both 1 1 and onto function. Therefore, its inverse exists. That inverse function is denoted as, for example, I am telling. So this is a function f is equal to sin x. Okay, now what is the domain here? Minus pi by 2 to, sorry, this is a minus pi by 2 to plus pi by 2 to minus 1 to 1 function. It is a bijection. Okay, now the inverse function is there now. So we have to give the inverse function notation. That notation is f inverse, that is equal as sin inverse of x. This is a sin x, this is sin inverse of x. The function name is sin inverse of x. For its domain is minus 1 to 1, range is minus pi by 2 to plus pi by 2. Okay, na? For y f is equal to sin x, of course the domain is from set of real numbers to real numbers, but we have restricted, we have cut the domain from minus pi by 2 to plus pi by 2. That domain only I have taken. Why? Because in that domain only the function is both 1 1 and onto function. So there exists a function from b to a, that is called inverse trigonometric function. Okay, na? I hope that you understand this inverse sine function. Okay, now I am going to write the clear cut definition of the sine function. Okay, hence I am going to define the function inverse sine function. Okay, now right, see here, the function f from minus pi by 2 to minus pi by comma pi by 2 to minus 1 to 1. See here, I have restricted the domain. I have cut the domain in both the directions. I have cut from minus pi by 2 to plus positive side, minus pi by 2 to minus infinity negative side I have cut it. Defined by f of x sin x is a bijection. Okay, now it is clearly a bijection. That means in this domain it is a bijection. If you extend the domain, it is not a bijection. Okay, right, it is a bijection. Then if it is a f, what is the inverse? F inverse. See here, this is a domain and it is a codomain, and it is a domain and it is a codomain. I have reversed it. Is also a bijection. Yes, it is also a bijection. Clearly, it is also a bijection. This function is called inverse sine function. And it is denoted by, see here, arc sin x or simply sin x. That means what? If your sine function is, if your sin x function is from minus pi by 2 to plus pi by 2 to close bracket minus 1 to 1, then your sine inverse of x is equal to close bracket 1 to 1 to minus pi by 2 to plus pi by 2. Understand this? So this is called sin x and it is sine inverse of x. Okay. So be careful here while observing this notation. It is not mean that sine inverse of x, it is not equal to 1 by sin x. Be careful about that. Sine inverse of x is not equal to 1 by sin x. Understand this? It is just a notation. we have given there is a new function is arised from when you interchange the domain and codomain, there is a new function arised. That function you have to give the name. The name of that function is sine inverse of x. Understand? Since it is a mother function is sin x, so therefore a new function name is sine inverse of x. But it does not mean that sine inverse of x means 1 by sin x. It does not mean that. For example, if it is 2 inverse, it is the equal to 1 by 2. Here x is a real number, but it is not a it is just a name of the function. So don't try to misunderstand that. Okay. So this is the definition, clear-cut definition of inverse sine function. Same applies, almost the same logic applies for cos, tan, cosecant, secant. Okay. There also, if you restrict the domain, we can make it into bijection. Once we make the bijection, it will inverse exist. Okay. So what are the domain and the codomains, all those things I will write it on a table. Try to understand this. I have written a very important table. So I have explained clearly about the sine inverse function, inverse of sine function. Same logic applies for remaining 6 trigonometric functions. For sine function, we restricted the domain from minus pi by 2 to plus pi by 2. Then its range is minus 1 to 1. So, as usual, we know that for inverse function, the domain will be minus 1 to 1, range is minus pi by 2 to plus 1, reverse. That means, so for sine function, minus pi by 2 to plus pi by 2 to minus 1 to 1. So this is the domain and it is the range. For inverse function, this will be the domain and it will be the range. So see, domain minus 1 to 1, range is minus pi by 2 to plus pi by 2, right. Similarly, for cos function, if you restrict the domain from 0 to pi, if you restrict the domain from 0 to pi, then the function is a bijection, therefore that is called inverse cosine function. For that function, domain is 0 to pi, range is minus 1 to 1. So here the inverse for inverse function, domain is minus 1 to 1 and the range is 0 to pi. Clear? Now, for tan inverse of x is equal to, so if you restrict the domain from minus pi by 2 to plus pi by 2, open bracket, minus pi by 2 to plus pi by 2. So you should not take pi by 2. Why? Because tan pi by 2 is not defined. So that means if the domain is restricted from minus pi by 2 to plus pi by 2, only you have taken, in that interval, the tan x function is a bijection, therefore its inverse exists. Okay. So therefore, what is the domain for their domain minus pi by 2 plus pi by 2, range is set of real numbers. For tan function, range is set of real numbers. So reverse it. The domain is set of real numbers and range is from minus pi by 2 to plus pi by 2. So mainly sine inverse of x, cos inverse of, tan inverse of x. These three functions are main functions. So you mostly concentrate, you must and should know this domain and range of inverse trigonometric function. These you know that. Why? Because the range of sine function is minus 1 to 1, the range of cos function is minus 1 to 1, the range of tan function is r. Same here, domain will come. Now where the domain is restricted, these three intervals are very important. Now coming to cosecant inverse, secant inverse, cot inverse x. So here also, so from minus pi by 2 to, see here minus pi by 2 to plus pi by 2, no. Here also the same domain, minus pi by 2 to plus pi by 2, except 0, try to understand here, except 0. Here also minus sin inverse of x, cosecant inverse of. You learn this thing in same sequential order. Sin inverse of x, cosecant inverse of x, cos inverse of x, secant inverse of x, tan inverse of x, cot inverse of x. In this order only you remember this. Now here, what is the range? Minus pi by 2 to plus pi by 2, same range only, but except 0. That's why here open bracket I have written. Open bracket means you have to, you should not take that point, that you should not take 0, 0 here. That's why union, this interval, that's here also 0 to pi. So 0 to pi only, see here 0 to pi except pi by 2. At pi by 2, the function is not defined. Okay, now, right. Secant inverse of x. Why? Because cos pi by 2 is 0, then secant pi by 2 is not defined. Okay, now, that's why. For tan inverse of x is minus pi by 2 to plus pi by 2 open bracket, but here 0 to pi, 0 to pi. So it is somewhat different. Okay, now coming to the, that is range. Now coming to the domain. So here also the domain is from minus 1 to 1. Domain is how much? Minus 1 to 1, but here except minus 1 to 1 remaining part. So from 1 to plus infinity, minus 1 to this side minus infinity. Okay, na? So here also minus 1, 1 includes, here also minus 1, 1 includes. Same here also, same logic, minus 1 to 1. From 1 to plus infinity, here minus 1 to minus infinity, this side, left side. R. For cot in tan inverse of x, domain is R. For cot inverse of x is also domain R. So very, very important table. The first thing what you have to remember is these three trigonometric ratios, sin inverse of x, cos inverse of x, tan inverse of x, their domains and ranges you should learn. Okay, na? So if you learn that, remaining also you can easily understand by seeing the domains and ranges of this main inverse trigonometric functions. Okay, na? I hope that you understand the domain and ranges of inverse trigonometric functions. Now what we are going to see, let us draw the graphs of inverse trigonometric functions. I am going to draw the graph of y is equal to sin inverse of x. That means inverse function of sin x. Okay. So first I have to in the basic concept is, while explaining the trigonometric functions, I have explained one thing. That is, the thing is, if this is the line y is equal to x line, okay, now if your function is y is equal to f of x, this is the curve is y is equal to f of x, its inverse function curve is just the image of y is equal to f of x with respect to the line y is equal to x. That means this will be the y is equal to f inverse of x graph. Understand? If it is your y function is y is equal to f of x curve, its inverse is nothing but it's just like the image of the curve with respect to the line y is equal to x, y is equal to f inverse of x. Okay, now just so here also this is the original sine function y is equal to sin x. Already you know that the sine function passes through the origin, its maximum value is 1 at the point pi by 2 and its minimum value is minus 1 at the point minus pi by 2. This is a inverse original sine function. Now to find the graph of its inverse, we have to first draw the line y is equal to x. So this is the y is equal to x line. This is the y is equal to x line. What is the image of y is equal to sin x? Image of y is equal to sin x is, this will be the image. Okay. So this is the line, its image will be like this. And it is the line original, its image will be like this. So this is the image of graph of y is equal to sin inverse of x. Understand this? So here like this it will come now. So this is the graph of the inverse trigonometric function y is equal to sin inverse of x. Okay, now so that means first to draw the original graph of sin x, cos x, tan x in the prescribed domain. So here our what is the restricted domain? Minus pi by 2 to plus pi by 2. That is the restricted domain. In that domain, draw the original graph. Sin x, cos x, tan x, right? And you draw the line y is equal to x line. y is equal to x line. Understand? So, y is equal to x line is passes through origin and makes 45 degrees with the x axis. Just take the image of your original graph with respect to the line y is equal to x. That gives the inverse graphs of inverse trigonometric functions. Okay. So, I have explained this y is equal to sin inverse of x. So, in your materials what you have, so for cos inverse of x, tan inverse of cosecant, secant, cot inverse of x graphs are also there. Just you go through those graphs. Okay na? So, first thing, draw the original graph y is equal to sin x, cos x, tan x in the prescribed domain, defined domain, and draw the line y is equal to x. Just you take the image, of the graph, that will give the inverse graph. Okay na? So, I hope that you understand this concept. Let us see some properties, some formulas which were related in the trigonometric functions, which are very, very useful for your solving the problems for JEE mains examinations. Let us see some properties of inverse trigonometric functions. So, this is a systematically you learn one by one. Okay, there are, so if you open your materials, you have so many formulas regarding inverse trigonometric functions. So, systematically learn the first basic properties of this trigonometric functions is, see here, sin inverse of x is equal to cosecant inverse of 1 by x. Remember that sin inverse of x is equal to cosecant inverse of x, but the condition is x should belongs to -1 to 1 and x should not be equal to 0. Okay now? Right. That means what? Here you have to take x is belongs to -1 to 1. That means whenever it is came, so that is equal to sin inverse of 1 by 2 is there, you can write it as cosecant inverse of 2. You can write it as cosecant inverse of 2. Why? Because first x should belongs to -1 to 1. Okay. So, here x belongs to -1 to 1. Therefore, sin inverse of 1 by 2 is equal to cosecant inverse of 2. But if it is more than 1 and you cannot write it as like this. Okay na? Right. That means what? You cannot write it as a sin inverse of 2 is equal to cosecant inverse of 1 by 2. You cannot write it as. Why? Because here 2 does not belongs to -1 to 1. This step is wrong. This step is wrong. Understand? The first thing is x should belongs to -1 to 1. Okay na? Right. Second also same thing. Cos inverse of x is equal to secant inverse of x, where x belongs to -1 to 1. Of course, x should not be equal to 0. Why? Because 1 by 0 is not defined. So, this is a very, very, very important. Very, very important. Here you will get two formulas. Tan inverse of x is equal to cot inverse of x for all x greater than 0. For all x greater than 0. Whereas, tan inverse of x is equal to minus pi plus cot inverse of x for all x less than 0. That means, if it is given that tan inverse of -1, this is equal to tan inverse of -1 is equal to minus pi plus cot inverse of 1 by -1 will come. Understand this? Understand this? That means, if it is x is less than 0, that is -1, then it is minus pi plus cot inverse of -1 come. If it x is more than 0, for example, tan inverse of 1 by root 3 is there, 1 by root 3 is there. This can be written as cot inverse of root 3. This can be written as. Understand this? So, these are the first things, basic formulas, properties of inverse trigonometric function. So, this type of properties are, so many properties are there. In the next class, I will explain some more properties regarding inverse trigonometric functions. So, dear students, I hope that you understand today's class very well. So, very, very easy chapter. This is a inverse trigonometric functions. So, in the next class, I will explain some more properties from inverse trigonometric functions. Okay. Until then, all the best.